All right, check. So good morning. My name is Mike Blefko. I am with SES Government Solutions in Reston, Virginia. SES is a global owner-operator of C and KU band geostationary satellites. Recently, we also have taken a majority stake ownership in O3b, which is a Ka band service that essentially provides a fiber-in-the-sky-like service to the warfighter. Today, I'd like to take a couple minutes to describe what that fiber-in-the-sky means to the warfighter. So specifically, a couple scenarios I'd like to discuss in the 10 minutes that we have. The fact that we can send mission-critical real-time HD video support for ISR from the forward deployed folks back to the folks in the rear in real time is what O3b provides. And then again, being able to take that real-time video and that analysis that occurs from that real-time video and push it back up to the warfighter for that situational awareness. Two small 85-centimeter reflectors deployed inside the 450-mile diameter spot beam provide a service, a fiber-like service. Terminals range from that 85 centimeter just shown to up to about 2.4 meters. And over the 85 to 2.4, we can deliver 300 by 100 megabits per second over the 85, as well as 600 by 600 megabits per second over the 2.4. The video shown here shows the handoff that occurs on the ground between the two terminals that are deployed within the spot beam. Essentially, one terminal follows the ascending satellite, and the second terminal follows the descending satellite. As it tracks across the sky, there's essentially a make-before-break connection that occurs. Since its inception in 2014, millions and millions of handovers in this configuration have occurred for our customers. So this is what occurs on the ground, and then in the air, we have the O3b satellite. There's 10 reflectors that form 10 spot beams on the face of the planet. And those 10 spot beams provide service to the customers that sign up for the service. Each satellite has telemetry and control beams, and then 10 individual beams that can go to any spot that the customer chooses. The video, as it progresses, gives a very good demonstration of how that system works in the air. The orange beams demonstrating the telemetry and control, and then the other beams being the customer beams that switch from region to region to region as the 12 satellites circulate the planet. And then a very simple switch in a make-before-break connection as they rotate around. So relative to geostationary satellites, which SES again owns 53 C and KU band satellites, the 12 MEO satellites, the Medium Earth Orbit satellites, they circulated about 8,000 kilometers from the Earth. With that closer in configuration, the latency of the constellation is much less than geostationary, typically in the range of about 150 milliseconds as compared to 500 milliseconds for geostationary satellites. So what really differentiates O3b? It's the high latency, it's the high throughput, the low latency. We can do 1.2 gigabits per second to the ground for our customers. The latency of 150 milliseconds, 130 to 150 milliseconds provides a real-time internet experience without the delay typically associated with geo types of solutions. It is about 30% less expensive than geostationary solutions. It's extremely flexible. The beams track in a steerable manner the customers on the ground. We're scalable anywhere from less than 25 megabits per second all the way up through 1.2 gigabit. And as I mentioned, the beam size is about 435 to 450 miles in diameter. I showed you the 12 satellites. Service began in 2014, and it is the fastest growing constellation in history. It also has been tested with KG devices over top of it to make sure that there is no packet loss during the handover from one beam to the next. Today, over 50 customers worldwide use the O3b constellation for this fiber-like connectivity. Customers are using this for 4G LTE bubbles. They're using it for large file transfer. The warfighter can be able to use it to take forward information, push it back to the rear in real time, and then again forward after the analytics has been completed. One of the most interesting customers is the Royal Caribbean customer. Royal Caribbean tracks its cruise ships around the Caribbean. Each cruise ship has more bandwidth than the entire cruise industry combined. The gateways that are already installed across the planet, which have been installed since 2014, start to your left in Hawaii, Vernon, Texas in the US, Peru and Brazil. There's a Nemea, Greece gateway, and it ends over here on the right with two gateways in Australia. Each of these gateways essentially allows the user to download to a spot on the internet and then essentially complete the service in a plus or minus 62 latitude arrangement. Pictures of the gateways are shown here. I like to show this slide just to demonstrate that all this hardware is in place today and services are operational for the 50 customers. So finally, the applications that can be used over this are truly a game-changing service. The high-resolution video. We recently did a demonstration at Washington Mediaport in Manassas, Virginia, which I invite you to come to our demo once you're in the Washington, D.C. area. We did a demonstration where we did 6 HD streaming videos over top of an O3b beam. That's HD with no pixelation, no buffering, streaming HD. This type of capability allows the ISR data that's collected in the field to be sent back again to the rear and then pushed forward to the warfighter for that situational awareness. Large file transfer. We've done a demonstration with a 100 gigabyte file over top of O3b. That 100 gigabyte file was transferred in 27 minutes. Today, a 100 gigabyte file transfer over GEO typically takes many, many hours. The real-time distribution, as I mentioned, tactical 4G LTE is being deployed commercially to many customers around the planet. They're using O3b as the backhaul because it's a low latency service. The voice service is excellent, and the data transmission is on par with all the different cellular companies that deploy today that have wired fiber. Remote voice networks and video analytics also are applications that our customers have used. So in conclusion, again, my name is Mike Blefko. I'm with SES Government Solutions. Our booth is right here beside the center here at booth 229. If you have more questions or you'd like to find out more information about this service, I'd be pleased to talk to you further. Thank you very much.